Hey guys, this is part 2 of our adaptations notes video, and in this part we're going to go back and talk about how adaptations happen. Charles Darwin, as we stated in the previous video, was the one that kind of recognized and put a name to it and came up with this idea of adaptations. Okay, and now we're going to explain how adaptations happen. Now, we know that adaptations are changes that occur over time. Okay, and they help an organism, a plant or an animal, okay, to be better fitted to its environment. Talking about Darwin's finches, we saw how the birds had developed a particular type of beak that was fitted, that was suited to eat the food that was available to it. So if it had large pieces of fruit, it developed a large husky beak in order to be able to eat those large pieces of fruit, versus the birds, okay, that maybe were only eating insects, had a very pointed beak and able to use that pointed beak to be able to pluck the insects off the ground and off of trees. So now we need to look at how that happens, because your first thought is, okay, you know, that changes within that one particular organism over its life. You know, you might think of me as a teacher. I need to have eyes in the back of my head to keep track of all you guys. So over the course of my lifetime, all of a sudden I develop eyes in the back of my head. That's not how it happens. It doesn't happen over the course of one organism's lifetime. Okay? It happens over several generations, several hundreds, several thousands of years of generation after generation after generation of these particular organisms. So let me give you a better example. So first off, we have mutations. Okay, now you've heard of mutations before. Mutations, usually think of a third arm sticking out, okay, or two heads. That is a mutation. Okay, that's a bad mutation, but we're also going to talk about good mutations. In general, a mutation is simply, it's a random change in genetic information. Okay, so somehow the genetic code, the DNA, when it's passed on from parents to offspring, somehow that code gets messed up. It's a pretty complex code. Okay, and somehow there's an error. That's a mutation. Okay, and it causes the offspring to be different in some shape, form, or fashion. Now, there can be good mutations, okay, good mutations in which it helps the offspring to survive better, or there can be bad mutations, okay, that cause the offspring to die sooner than it should. Okay, so good mutations help the organism to live longer. Bad mutations are going to cause the organism to die. Okay, so let's look at some examples of mutations. So here's a mutation. Okay, so I've got this jaguar here. Okay, and on the left side I have this black jaguar. On the right I've got a traditional, gold-colored, yellow-colored with black spots jaguar. Now the black one is a mutation. Okay, somehow in that genetic DNA, somehow the genetic code was passed on from the parents to this offspring here, okay, got changed. And instead of being gold colored like the one on the right, he's black. Now, this is actually a good mutation because jaguars are nocturnal, they're nighttime hunters. Okay, meaning a black jaguar is going to have is going to be benefited. He's going to have an advantage over the other jaguars because he's black. It's going to be harder for his prey to see him as he hunts at night because he's going to blend in with his black surroundings. That's a good mutation. And versus the one on the right, you know, he's just kind of left out there to hunt normally. Now, this isn't a really big mutation here, but it's a slight one. Now, what's going to happen is over time, this black one is going to be a little bit more successful than this gold one. Okay, he's going to be a little bit more successful because he has that natural camouflage. Okay, which means he's going to live longer, which means he's going to have more babies, and he's going to be able to pass on that black color to more of his offspring. And they, in turn, will be more successful than the gold ones. So let's look at the opposite of this. And let's look at a bad mutation. Okay, so this is where you would think of two heads. All right, so here I have a two-headed calf. Okay, this is a harmful or bad mutation. I've got a two-headed calf. So somehow, the genetic code got messed up, and when this offspring was born, okay, it had two heads. This is a bad mutation. Okay, it's going to hurt this organism's ability to survive. Okay, if it was in nature, it would die off pretty quickly, just because it would not be able to function properly. And bad mutations die off pretty quick. Therefore, bad mutations are not usually passed on to their offspring. Okay, bad mutations die with the organism pretty quickly, and it doesn't have an opportunity to reproduce and have offspring that have that same mutation. So you can see in the case of the black jaguar, it's a good mutation. It's going to help it live longer. It's going to be able to pass that mutation on to its offspring. Okay, and then bad, going to cut short. Okay, so mutations, good mutations can lead to what we call variation. Variation is just differences. So here's the same bird. I've got, like Darwin's finches, I've got parakeets here. I've got kind of this yellow and green parakeet. I've got this blue parakeet. And I've got this other one that's a green color, but he's got different colored markings. These are all parakeets. At some point in time, they were all, let's say, this parakeet right here. But there was a mutation in their DNA, a change in their DNA, and then I've got a blue one. And then somehow, somewhere else along the line, there was a change in the DNA, and I got this other parakeet that has a different coloration. Okay, these are not necessarily bad mutations. They're not necessarily good, but they lead to variation, differences in the population. So now I have all sorts of different colored parakeets. Okay, maybe in nature, one is a little bit beneficial, more beneficial to the other, and therefore be more dominant. Okay, but these are just little mess ups in genetic code when it gets passed on from parent to offspring. Okay, so let's look at natural selection, and this is really where adaptations come into play, and that's what I was alluding to earlier with the jaguar and so forth. So natural selection is where I have an organism that has a particular mutation that it helps it to survive. Okay, we coined the phrase survival of the fittest. The stronger organisms, the stronger mutations help the organism to survive. Bad mutations are going to cause the organism to die. Okay, so in the case of the black jaguar, he has a strong mutation that's good. It's going to help him survive, and he's going to be able to pass that mutation off to his offspring. Versus the gold one, not necessarily a bad, but he's not going to be as successful as the black jaguar. Or maybe the gold jaguar, okay, maybe he turns even a different color. Maybe he turns into, whatever, neon green. Okay, and it helps him to be easily spotted, and therefore he's not a good hunter. He's not successful because his coat color is so bright that all of his prey can see him coming, and he's not successful at hunting, and therefore he starves off and dies. So natural selection is simply a process where the stronger organisms survive longer. Let me give you an example of natural selection. So here I've got this this bird. Okay, I've got these black crows here. Okay, and these black crows, they like the green beetles. Okay, they're tasty. They're what they used to. And what happens is these little brown beetles right here, brown orange beetles, maybe they have a sour taste. And those crows don't like those colored beetles. They have a sour taste to them. They just don't taste good to those crows. So what happens is these crows are going to munch down on the green ones. They love the green ones. And they're going to continue to munch the green ones, but they're going to ignore the gold ones, the brown ones here, because they don't like the way they taste. So if this happens over time, you're going to start to see over generation and generation, there's going to be fewer of the green ones because the crows are eating all the green ones up. And what is left behind is going to be these brown, orange colored beetles. Okay? And if we go another generation, now the crows have eaten all of the green ones. Okay? They've eaten all these green ones. They're all gone. And what's left behind? Nothing but the gold ones. Excuse me, the brown ones, the orange colored ones. Okay? So this would be how a mutation, maybe all of a sudden, a beetle changed and he was not a good flavor or in a different color, there's a mutation there, and the crows started ignoring those. But over generation and generation, you start to see a gradual change in the population. Okay, so the green ones have gone away, and we have these mutated, brown, orange colored ones that are now available, and they're thriving because the crows don't like those. Okay, they don't like the way those taste, and they know that color is off. So that's how natural selection, survival of the fittest, helps an organism to survive, and therefore that's how an adaptation gets passed on. Okay, so that's it for part 2 of this video and adaptations. We'll continue to talk more about adaptations and how we make adaptations happen as humans, as we purposely cause adaptations to happen through selective breeding in our next video.